All right, my friends, for part A, show the steps necessary to convert this equation into rectangular form. So this is supposed to be your outcome. And so let's start with r equals 2 over 1 minus, and then sooner or later you need to replace cosine with x over r. Many ways to go through this problem, but I will be looking for you at some point to do that swap where you take cosine and replace x over r, somewhere in the problem. It doesn't especially have to be on that first step. And then next, you would need to clear the fraction. Sooner or later, you had to do that as well. So this is what it would look like to do that. And then you can distribute Rn, and then add x over, and then square both sides. Get r squared equals, and then squaring the right side would give you x squared plus 4x plus 4. And then r squared is x squared plus y squared. And then the x squareds would vanish or subtract out, and so you'd be left with y squared equals 4x plus 4, which is what they asked you to show there. Okay. Let's see, so 1 point for replacing cosine of x with x over r somewhere in your work. Let's see, 1 point for somewhere in your work replacing r squared with x squared plus y squared. Okay, 1 point for, and I know this is a little elementary, but it actually makes sense, or actually, no, wait, that's 2 points, right? Let's see, what's another point? Oh, okay, 1 point for when you square x plus 2 squared, getting x squared plus 4x plus 4. There's a common mistake there. So 1 point for not doing the common mistake. Anyway, and then the last 2 points are for a very clear step-by-step process where, you know, it's very obvious that you knew what you were doing. Every step, you didn't have any like sudden like, now a miracle occurred and I got the answer because I told you what it was. But it, you know, a step-by-step solution. So let's word it this way: clear step-by-step solution with no miracles. So you know, I know a couple of you kind of like weren't sure what to do, so you just kind of out of desperation just wrote the answer at the end. Anyway, that would be one of those miracles that I'm referring to here. There you go, and that would be the last 2 points. So that's 5 points. Okay, for part B, graph the function on the rectangular coordinate plane. So I'd expect to see you completing the square here. So, or actually, it's already completed, sorry. Factoring the 4 out, that would be a good idea. And then dividing it over. And I know a lot, you know, I think this is probably the best format to leave it in, but some people would subtract the y over as well. Totally up to you. But in this case, you have an x equals y squared parent function with a stretch of 1/4, and it got shifted to the left one. So from here, we're going to go out 1 and then over just 1/4 of a unit. From your vertex, out 2, and then normally 2 squared is 4, but you're going 1/4 of that, so just 1. And then these would be some fine points of accuracy to put in. I remember I always expect 5 for parabolas, or pretty much always, unless it's like totally ridiculous to put the other ones. There you go. Okay, let's see, points for this part. You get 1 point for having a parabola graph at all. Actually, no, 1 point having a parabola that opens to the right. And then 2 points for having the vertex at the right place. So the vertex at -1, 0, that's 2 points, 1 for having the x coordinate right, 1 for having the y coordinate right. You didn't have to label it, but it should be there. And then the last 2 points for this part will be 1/2 of a point per additional point of accuracy. And that adds up to 5. All right, my friends, part C, find the focus and equation of the directrix, add the coordinates of the focus and the equation of the directrix to your graph. For part B, show clear work that supports your answer. So some work you could do is take the stretch factor of 1/4 and set it equal to 1/4p, and then that would lead you to know that p is 1. Another option would be to just set 4 equal to 4p. You get to the same place. Once you know what p is, you could you'll need to know how to translate that. So p is the distance from your vertex to your focus. So your focus would have been at 0, 0, and then your directrix would have been a unit in the other way, and it would need to be this vertical. Remember, your directrix is just a graphing aid, so it needs to be dashed. So the equation of your that directrix would be x equals -2. Okay, points for this. 1 point for finding p, showing work to get there. 1 point for showing that the focus is at 0, 0, and then 1 point for drawing that vertical directrix with the dashed line and then labeling its equation with x equaling -2.